In this video, we're going to be talking about describing the center of a data set. So suppose we want to know the mean length of all the fish in Lake Louisville. Is that a value that is known? Can we find it out? At any given point in time, how many values are there for the mean length of the fish in the lake? What we're talking about is a population characteristic. This is a fixed value about the population, and it's typically unknown. So let's go back to our fish in Lake Louisville. So suppose we want to know the mean length of all the fish in Lake Louisville. What can we do to estimate this unknown population characteristic? We can take a statistic, which is a value that is calculated from a sample. Let's review quickly the measures of central tendency. We have mode, which is the observation that occurs the most often, and it can be more than one mode. So if all the values occur only once, then there is no mode as well. It's not used as often as mean and median. Now the median is the middle value of the data. It divides the observations in half. To find it, you list the observations in numerical order, and then you find the middle value, or values, because when we're finding the sample median, if n, meaning the size of our sample, is odd, then there will just be one single middle value. But if n is even, then we'll have two middle values, and we will need to take the average of that, meaning we'll need to add them together and divide by 2. So again, n is our sample size. So suppose that we catch 5 fish, a sample size of 5 fish from the lake, and the lengths of the fish in inches are listed here below. We want to find the median length of the fish. So we have 3, 4, 5, 8, and 10. Our numbers are in order, and n is odd. So to find the middle observation, we look at the outside, then the next one, and then boom, there it is. The median length of fish is 5 inches. So now suppose that we catch 6 fish from the lake. The median length is going to be what? Well, the numbers are in order, and this time n is even. So we're going to find 2 middle observations. So we'll go our outside, so 3 and 10, and 4 and 8, and we're at 5 and 6. Now that we're here, we're going to average these together. So we're going to add 5 and 6, divide it by 2. So 5 plus 6 is 11, and 11 divided by 2 is 5.5. So our median length here is 5.5 inches. The mean is an arithmetic average. We use mu to represent a population mean. Mu is the lowercase Greek letter mu. We use x bar to represent a sample mean. So mu is our population characteristic, and x bar is our statistic. So the formula for calculating our x bar is the sum from I to n, where I is 1, of your x sub I, all divided by n. Sigma is the capital Greek letter sigma, and it means to sum the values that follow after that. So suppose that we catch 6 fish from the lake, and now we want to find the mean length of the fish. So we're going to use our 3, 4, 5, 6, 8, 10 sample. So to find the mean length of fish, we're going to add the observations and divide by n. So we'll add our 3, 4, 5, 6, 8, 10, and then divide by 6. When we do that, we're going to find that our x bar is the value 6. Let's go over how we would find this using our calculator. So I'm going to pull up my calculator here, and the first thing that I'm going to do is I'm going to create a list. So I'm going to come over here to Stat and Edit, and I'm going to create a list of my values. Remember the fish that we caught? We had a fish of 3, a length of 4, a length of 5, a length of 6, a length of 8, oops, go back up, 6, 8, and 10. Oops, 10. There we go. So I have my list. I've created my list. Now the next thing that I'm going to do is I'm going to come to Stat, then I'm going to arrow over to Calculate, and I'm going to choose this one variable statistic, and I'm going to hit Enter, and I'm going to choose the list I want, so list 1, and I'm going to hit Enter, and here we see that it's going to calculate my X bar, which is my mean. We'll talk about some of the other stuff later. And then as I scroll down, it gives me my sample size was 6, so it gives me my Q1, but it also gives me my median of 5.5. So it gives me the values that I need here. It gives me my Q3, my max, my standard deviation. All those different pieces are right here. And so you're able to use your calculator to also find those values. But it's still important to make sure that you know the equation. So now we're going to find how each observation deviates from that mean. So we're going to take our x and minus our x bar. This is the deviation from the mean. So I would take 3 minus 6, and that would give me -3. So I want you to go ahead and I want you to find the rest of the deviations from the mean. I'm going to push pause and do that. Then when you're done, push play, and let's see if you're right. So the rest of these deviations from the mean are -2, -1, 0, 2, and 4. So what is the sum of the deviations from the mean? Go ahead and calculate that sum really quick. You should have gotten a sum of 0. Will the sum always equal 0? And the answer to that is yes, it will. The mean is considered the balance point for the distribution because it balances the positive and the negative deviations. Imagine a ruler with pennies placed at 3 inches, 4 inches, 5 inches, 6 inches, 8 inches, and 10 inches. Right? We put the pennies there. Well, in order to balance your ruler on your finger, you would need to place your finger at the mean of 6. The mean, again, is the balance point of the distribution. Well, let's say that we take those points that we have, those values, and we replace the 10 with a 15. What do you think will happen to the median and the mean if we do that? For this data set, the median is going to be 5.5. And the mean is going to be 6.833. What happened to that value? What happened to our mean value? That's right, it went up. What if we replace now that 15 with a 20? What do you think is going to happen to the median and to the mean if we replace that? So here the median is going to be 5.5. And the mean, after we add up all of our values and divide by 6, is going to be 7.667. So what happened here? That's right, it went up. But the median hasn't changed. Well, some statistics they're just not affected by extreme values. Is the median affected by an extreme value? No, it's not. Is the mean affected by extreme values? Yes, we just saw that when we changed the 10 to a 15 and then the 15 to a 20. So let's suppose that we catch a sample size of 20 fish from the following lengths, right? We're going to create a histogram for the lengths of the fish with a class width of 1. So create that histogram. And then we're going to calculate the mean and the median values. Now is a great time to practice using your calculator to do that. So go into Stat, create a list. Then, when you're done, calculate a one variable statistic. So one var stat. And calculate your mean and your median. So push pause and do that. And then push play when you're done, and let's see if you were right. So here we get a median of 6.5. And we get a mean of 6.5. Look at the placement of the mean and the median in this symmetrical data distribution. What do you notice about them? We see that they're in the same place. Now, suppose we caught a sample of 20 fish, and this time we have these distributions. Notice how they've changed. So we're going to create a histogram for the lengths of the fish, and again we're going to use that class width of 1. So go ahead and do that, and then when you're done, so push pause and go ahead and do that, and then when you're done, push play, and let's see if it's right. So here we have our histogram, and we're going to go ahead and we're going to calculate the mean and the median values here. Here we see that we have a median of 5.5, and we have a mean value of 6.8. Look at the placement of the mean and the median in this skewed distribution. They're no longer together. So let's do one more sample of 20 fish. So suppose we catch a sample of 20 fish that have the following lengths. I want you to go ahead and create a histogram for these lengths of fish. Use a class width of 1. So go ahead and push pause and do that, and then when you're done, push play, and we'll see if you're right. So here our histogram looks like this from our data set. So go ahead and calculate the mean and the median values. Push pause and do this, and then push play when you're done, and we'll check and see if you're right. So here we have a median value of 8.5 and a mean value of 7.75. Look at the placement here of the mean and the median in this skewed distribution. Notice that our mean and median are not in the same place, and our median is actually to the left of our mean is to the left of our median. So for a brief recap, in a symmetrical distribution, the mean and the median are going to be equal. And in a skewed distribution, the mean is always pulled in the direction of the skewedness. In a symmetrical distribution, you should always report the mean value. And in a skewed distribution, the median should be reported as the measure of the center.